to do today is kind of some review. Okay, it's all stuff that you should be able to do, but we're going to kind of combine it all together. Okay, so for unit 1.10, and again, this is going to be the last thing that we do for this unit before our test. Okay, we are going to have some review days, but the last one we're doing before our test is we are going to compare real numbers. Okay, now, a couple of you have asked you, what's a fake number? Okay, there's no such thing as a fake number, but there is something once you get to Algebra 2 called an imaginary number. Okay, so right now, you just need to know that there is things other than real numbers, okay? Up to this point, you only know real numbers.
Wait, so why do you have imaginary numbers?
You will get there in a couple years. Okay, just understand that there is something called imaginary numbers. You don't need to know anything about them. For right now, we're just comparing real numbers because that's the only thing that we know. Okay, so your instructions are going to ask you to place in order from least to greatest. Okay, place in order from least to greatest. For example number 1, I would like you to place in order from least to greatest. Let's place the square root of 25. I would like you to also place 5.15 as well as the cube root of 216, and let's go 510%. Place in order from least to greatest.
I don't get it.
You're just writing it down for right now. Place in order from least to greatest. Right now, these are written in different forms, okay? This is written in a square root form. This is in a decimal form. This is in a cube root form. And this one's written in a percent form. That's a problem, okay? It's kind of like we want to compare things that are in the same form. So what you actually have to do is we're going to figure out how can I write these all in the same form? What form do you think they would all have kind of in common? What could I change them all to be? We could change them all to be decimals. Okay, that's exactly right. So we want to write them in decimals. Okay, and I want you to, so first thing we want to do is simplify what we can. So can you simplify what is root 25 equal to? What's root 25 equal to? 5. Do I have to change it into decimals? Why do I not really have to change it into decimals? Because it's already a whole number. So really, this is like 5.0, right? So it's not like the ones that we just did where I'm asking you to find square root of 20. That isn't an exact, what's called a perfect square, okay? I am only going to give you ones on these when we're comparing them and putting them in order that are either perfect squares or perfect cubes. You are not going to have to find them to the nearest tenth like what we just did in 1.9. Okay, so 5. 5.15 is already in decimal form. Okay, so step 1 is basically put in decimal form. Okay, so change or put in decimal form. That's the first thing you're going to need to do for these types of problems. Then, what is the cube root of 216? What is the cube root of 216? 6. That's one that you can either look at a chart or you should just have memorized. Okay, that's one that I think you should probably know. How do you change something that's in a percentage? What is 510%? What's 100% equal to? 1. So if we were going from 100% to just 1, how many decimal places should a percentage have? Hold on. So how many decimal places should a percent have? Yes, 2. So basically what we're going to do here is we're going to put in 2 decimal places to change from a percent to a decimal. Okay? So we're going to write ourselves a little note, okay? To go from percent to decimal, put in 2 decimal places. Okay, so to go from percent to decimal, you need to put in 2 decimal places. So if I wrote in 2 decimal places, what would this number be equal to? 5.10. Okay, is it absolutely necessary to put the 0? No. But for this purpose, I just want to write it in because I am going to put in 2 decimal places. Then, step 2, hey guys, it's my turn to be talking. You need to be listening. Step 2 is to place each decimal on a number line. So we are going to make one number line. Okay, I'm going to make one number line, and I want you to put all these numbers on that number line. So what do you think my number line should be between? Do I really need to go from like 0 all the way to 10? No, what are all these numbers in between? 5 and 6. So all I really want you to do is put what the numbers are in between. So my first number is 5, and we know we're going to go in between 5 and 6. Look, you've already placed 2 of your numbers. One number is at 5, one number is at 6. Then all you really have to do is put these other ones in between them. Okay? Where should 5.15 go? Is it like right in the middle of it, between 5 and 6? Where is it closer to? Closer to 5. Okay, so I'd like you to place that 5.15. I'm just going to say it's about, I don't know, right here. Okay, 5.15. Where would be 5.10? Is it on the left or on the right of that? Amber?
Right?
Is 5.15, or excuse me, is 5.10 bigger or smaller than 5.15? Smaller, so that means it goes on the left. Okay, so this would be 5.10. Okay, that would be 5.10. So you're going to put these on your number line. Then, based on where they are, we're going to write them in order from least to greatest. Okay, so in order from least to greatest would be 5, then 5.10, then 5.15, then 6. Okay, so place each number on a number line. Step 3 is to write them in order from least to greatest. And the last step here is you need to change back to original form. Change back to original form. So I can't leave my answer like this, okay? I want to figure out how do you write them in from least to greatest in this form. So I want you to change them back to be their original form, okay? And that's how your answer needs to look, in the original form. So where did my 5 come from? What was its original form? Root 25. Okay, so that is the least number. Where did 5.10 come from? What form? 510%. Where did 5.15 come from? It started that way. So that one stays, 5.15. And finally, where did 6 come from? Cube root of 216. This is the actual answer that I am looking for. Okay, this is the actual answer that I am looking for. Question, Amber. Oh, I thought you were doing that. Yes, Court.
Why do we need to put it on a number line?
Because I just want you'll see. Because I said so. Because that's the process I'd like you to go through for right now. Now, eventually, do you have to put it on a number line? No, not necessarily. But go with me for just a minute. Going on an adventure. Okay, just follow with me for just a minute, okay? So, anyone have questions on how I did that? You feel pretty okay about that? Okay, just putting stuff on a number line. Let's try another one. Number 2. Okay, I'm doing the same thing. I'm still following the place in order from least to greatest instructions. Okay, we are doing the same thing with these instructions. I would like you to place negative, this is where it gets tricky, okay, negative 320%, negative 320%, as well as negative cube root of 27, negative root 16, and negative 3.5. Those 4. Place those in order from least to greatest. Write it down, Dustin. Write it down. Place those in order from least to greatest. Place those in order from least to greatest. So, Court was asking earlier, why do I have to put these on the number line? Okay? The reason is when you deal with the negatives, it's just better to see it that way. Okay? It's just easier to see it written on a number line than it is like in your head. Okay? A lot of people are what's called visual learners, so you need to see it. Okay? To understand things, for it to like cement in your head. This is one of those times. So maybe it's my fault that you have to put it on a number line because I need to see it. So you can blame me. Just can. Say it again. It's always Miss Coon's fault. When in doubt, it's Miss Coon's fault. That can be your motto from now on in math. When in doubt, it's Miss Coon's fault. So where do you think I'm starting here? What do I do first? Got to change them, exactly. Okay, so we're going to follow those exact same steps. Let's write these in decimal form. So what is negative 320% in decimal form? How many decimal places should I put in? 2. Put in 2. Okay, even if that means a 0 is after that. So it's really like negative 3.2. Okay, what is cube root of 27?
Negative 3.
This is just, it has a negative out front. Okay, even if it's negative, that just means you put a negative out front. Okay, it doesn't change anything about what's underneath that radical. Okay, and what is the cube root of 27? 3. Okay, remember I told you, I promised they're going to be nice ones. Okay, you're not going to have to do like that weird decimal thing where you multiply and figure them out. Okay, negative root 16.
4.
Negative 4, right? Don't lose your negative, it'll mess you up. And then finally, negative 3.5. Now, when we put these on a number line, between which 2 numbers are these all going to be in between? Negative 3 and negative 4. But remember, once we go negative, which one's on the left? Is negative, if I put 2 points here, which one's on the left? Negative 3 or negative 4? Negative 4. Okay, so think about your number line. Okay, think about your number line. So negative 3 and negative 4. Now, you've already placed 2 of your numbers. You're good. Now, let's place our others. Where would negative 3.2 go? Closer to negative 4 or closer to negative 3, Amber?
Negative 3.
Closer to negative 3. So I'm going to say it's about right here. Okay, it doesn't have to be perfect, but I'd like you to do, relatively a good job. Okay, so negative 3.2. Then I already placed my negative 3. I already placed my negative 4. Now I want you to place negative 3.5. Where do you think that is in relation to negative 4 and negative 3? It's like in the middle, exactly. It should be right about in the middle between negative 3 and negative 4. Okay, that's what I'm looking for. It doesn't have to be perfect, but I'd like it to kind of make sense. Okay, basically, I want you to make this so your explanations, okay, and on your test, when you have to explain and use words, I want you to explain it so that if I gave it to a 3rd grader, they would understand. Okay, that's how good your explanations need to be. And that's where I want you guys to, when you're thinking about it, I want you to think about how would I explain this to a 3rd grader? Okay, That's what I want your explanations to look like, so that you could teach someone else what you're doing if I had no idea. So for instance, we're going to think of a third grader, or Ashley might laugh at this because she knows my husband, okay? My husband does not understand math. He is like not a math person, okay? I want you to explain it so that if I gave my husband your test, he could figure it out. He would understand what you're doing. He's not good at math, okay? He's like a third grader in math. He is in math, you're correct. He is not smarter than a fifth grader in math. He's just not. But I love him, but it's okay. Hopefully my children take after me.
You look over that.
Yeah, that wasn't a prerequisite to why I married him, but thanks. Okay, so for this one, now, so I put them on a number line. Then let's write them in order from least to greatest. So -4. So remember, when we're going from least to greatest, it's always from the left to the right. So -4, -3.5, -3.2, yes. And finally, -3. Okay, so I write them. So these are our steps, basically. Change to a decimal. Put it on the number line. Oops, sorry, too far. Write it from least to greatest. And then your last step is going to be change it back to the original form. So where did my -4 come from? What was its original form? -√16. Where did my -3.5 come from? -3.5. It didn't change forms. Okay, where did -3.2 come from? -320%. And then finally, where did -3 come from? Cube root 27. Okay, that's your answer. I am going to give you a worksheet about this. It only has 6 problems. So your homework is to finish what did I give you? 10 problems for 1.9 and 6 problems for 1.10. That is your homework. I will collect both of them tomorrow. Okay, I'll write it up on the board just in case.